Do you see the other projector cable? Hey, there is another projector cable for that.
For my slides?
Yep. So
I'm going to use the slides. You are? Yeah.
Which one, right? So we're supposed to. Hello, good afternoon. Even if you're not here for the routing area meeting, you're welcome to stay. We have beer, we have OSPF. Oh wait, we have BGP running link state now. Anything you want. So I didn't mean to kick everyone out, but now that they left, now it's quiet. So this is the routing area meeting. This is IETF 96 in Berlin. I hope everyone's in the right place. As all the meetings, please note well, disclose IPR, read everything. You already have seen this at least 5 times. There's also what we usually put up here, which is information around resources for the area, the wiki, etc. Yeah, different things there. And all of you should also be including or be seeing in your working group meetings this other slide about document reviews. It is very, very, very important for everyone in the IETF that we have quality documents. That is, in fact, the mission of the IETF, to make the internet run better by producing high-quality documents. Please review documents, review other people's documents, ask them to review your documents, et cetera, et cetera, et cetera. This is the agenda for today. We're going to have our continuing series on routing technology. Justin and Stan are going to talk about MANET, today. Then Ross is going to talk about complexity in protocol design. Then we're going to have Christian talking about the code match project, and we're hoping that the whole area engages in that early. You may have already heard about some of this before in plenaries and other places. And then we're going to have the working group BOF and working group reports towards the end. And if we have time, we will have still 10 minutes to any other thing that you guys want to talk about. Does anyone have anything they want to change in the agenda? Additions, no deletions are permitted. Huh? Okay. So the area status, we have still the same working groups as before. We didn't close any working groups. We do have a new working group, which is the Babel working group. We have 2 new chairs, of course, for that working group, who I don't see here yet. Well, no, actually, Donald is right here. Donald is, wave, you can get up and turn around and, look. Yeah, there you go. There's Donald right there. And the other new chair is Russ White for Babel. Russ is not here. Russ also accepted the position of becoming chair of I2RS. And we have Sam Aldrin, who I don't see here either. So we need to train those new chairs to make sure that they're here where they have to be. We did, as part of the status, we did recharter 2 working groups this time. That's a good thing because, that means they're making progress, right? They're moving along. We're doing things, at least.
Okay, and we regretfully say, but of course we congratulate him very much and wish him all the best. But Ross Callan will be retiring after this IETF, and he's currently, of course, the MPOS co-chair. But in the past, he has been the routing AD and many, many other roles. So, Ross, take a bow, and we thank you.
So besides all that, for those of you who don't know, Ross was at the first ever IETF. And I don't know.
Before my time.
Way before my time, too. So I'm going to guess that he's been to probably 90 IETFs at least. 89 IETFs. Okay, there you go. So there's been a couple of let's just here there, but definite long and prestigious career. Very hard shoes to fill for all of us in following what he's done. That's what this is going to be.
So we thought we'd try something new this time as well. We know that there are a number of people interested and involved in various open source projects that are related into the routing area. We care a lot about running code as well as, the rough consensus and getting it written down. And so we thought that we'd like to invite people who are involved in open source to come meet with us and tell us how the interactions are going with the IETF and what we could learn from them, they could learn from us, and, generally look around the room and realize there's more than 2. So hopefully, if you are able to make it, that would be great. Thank you. Oh, but you do have to bring your own coffee.
If you bring coffee for the ADs, that would be very nice as well. Yes. That would be even better. Okay, so I'll come back to this later. So we're going to start our agenda. Stan and Justin, you're up. So I said before, this is part of our continuing series of letting everyone know what the heck we do in routing. And this is a Manet working group overview. There's that. And you can take that microphone, yes.
Okay, good afternoon, everybody. I'm Stan Ratliff, and we're here to talk about MANA networks. So the question is, what is a MANA? These networks are typically radio-based. They've got very dynamic topologies, a very dynamic mobility profile, if you will. They're constantly changing. Most of them operate on bandwidth-constrained links, radio links. They're also involved in, or they have energy constraints associated with them. There's only so much battery available. Limited physical security, lots and lots and lots of wireless. So they're radically different than the normal fixed wired networks. So to kind of drill down on that a little bit more, in typical wired networks, very high speed links, very low speed transmission rates, or very low error rates, excuse me. On optical links, for instance, you measure errors in bits per quarter. Topology changes are extremely rare. They're typically scheduled weeks or months in advance. Very planned events, and they follow a very strict hierarchical structure. On the other hand, when you talk about ad hoc networks, one of the base cases we keep talking about is after Hurricane Katrina. Right? The infrastructure was completely gone, so everything had to be brought in. They're compared to the wireless, or compared to the wired networks, they're very low speed links. They're very error prone. For example, on radio links, if you get a 50% successful reception rate, you're actually doing pretty good. So if you receive half the packets I launch, we're actually doing pretty well with these networks. So the rapid topology changes, it causes a lot of issues and concerns with things like addressing schemes, subnet schemes, and you have to have the network working even in harsh physical environments. In terms of radio types, there's a breadth of radio types that are that can be employed, anywhere from TDMA technology, point-to-point beams, TDMA satellite technology, all the way to omnidirectional broadcast type radios. Think 802.11 and variants of 802.11. So it's a wide range of radio types that get employed. For us, the base use case, we always go back to omnidirectional broadcast, multicast capable radios. And again, with multicast transmissions, you have a single transmission, a single send that everybody receives, unlike the point-to-point cases where the packet has to actually be replicated. So on addressing, here's an extremely simplistic wired network case, this straight from the book of Duh, using three subnets, nothing exciting. But in the wireless case, let's talk about a disaster recovery case. For instance, the fire brigades in California that wind up there every summer. You have brigades from different areas of the country. They all come in. They've all got their own internet addressing scheme. It was all done with a lot of thought and a lot of care in mind, and it works for them. But you bring them all together from different areas of the country. You throw them together. You tell them go out and fight the fire. So we deploy our scenario here. Oops. We wind up with bits and pieces of each and every individual unit in almost every spot. And what's the impact of that? The impact is that subnet structures tend to break down really quickly in these networks. They don't work, or they at least don't work really well. They don't work well at all. In terms of address assignment schemes, for instance, people say, well, why don't you just have a DHCP server? Why don't you just put a DHCP server out there? And you can do that with these mobile networks, but Odds on favorite is that your vehicle with the DHCP server will be the one that gets burned up in the fire. Or in the military case, for instance, I had a military guy once tell me, yeah, a valid targeting scheme is to find the vehicle with the most number of antennas on it and shoot that one first. So there goes your DHCP server, or your SIP server, or, you know, it's always the most important piece of equipment that you seem to lose coming right out of the chute. So another point there is that if you were to reacquire addresses as you're moving around in order to maintain the right hierarchical scheme, obviously you break TCP sessions, because at the end of the day, these folks want to use standard off-the-shelf apps for Jabber or for sharing video and those types of things. Yeah, so
that's kind of a summary on what MANA is and is supposed to be, and what kind of physical networks we're looking to deploy MANA technology on. If you go to the MANA page and you look at the RFCs, you get something that's even messier than this. It's a whole bunch of RFCs and who knows what's what. Well, hopefully we can clear up some of that here today. I'm going to do a little history on the MANA, and we've been around a long time. I wasn't here at the beginning of MANA, but my boss was, so I kind of have a view on how it's evolved over time. In the beginning, we were chartered to work on these types of networks, and 4 competing protocols were developed, and they're all experimental protocols. At the time, we didn't know how well they would work, or if they would work at all, what deployments they would work. Here's kind of the timeline. And there were 4 protocols, and they all worked differently. There were 2 that were reactive, and there were 2 that were proactive. And proactive is that you would learn the routes of all of the nodes in the network, and reactive is you would only learn routes when you needed to know how to get to a destination. So no traffic would be sent over the network, including control traffic, if no packets needed to be routed anywhere. You can see these kind of overlap timeline-wise. MANA was rechartered, and we were rechartered to do 1 proactive and 1 reactive standard protocol. And we took on the approach of, instead of making standalone protocols, we were going to use a building block approach and break things down. And some of those pieces are, we wanted to make a common packet format. We wanted to have a hello protocol, because that was somewhat common among the proactive routing protocols and useful for reactive ones as well. And make a generalized multicast protocol. We developed some extensions based upon this framework, and those are various RFCs that you saw in the last one. And today we're currently, from 2010, we're building a multicast. We're redoing the multicast. We built SMF, which I'll go over in this presentation, but we want to make it in the same way we redid the routing protocols. We want to make a building block approach for the multicast that we've developed. And the other bit here is a radio to router interface. This is something that was missed, and we've wanted since, I think, almost the very beginning. When I started work on this in 2001, maybe even 2000, you'd put the radio card in, or a Wi-Fi card in, and the drivers, lots of code would use specific drivers for specific cards because they wanted to read stuff off of the radio. Well, a new radio came along, you get a new driver, everything would break. So we went away from that, but there was no standard way of getting that information. And so we've developed, we're trying to develop and are developing a radio to router interface so that we can use that, leverage that information. Here is an organizational view of all of the RFCs that I was just talking about. At the top, we call it the packet building block, and I'll get into detail on that. On the left, we have some companion RFCs that provide things like security and timing and address IANA. In the middle, you have NHDP, which stands for Neighborhood Discovery Protocol. It's a hello protocol that's, again, I will get into later in this. You have SMF, which is a simplified multicast forwarding engine, and that's an experimental RFC. We're hoping to redo that in the next charter. Or we are chartered to do the next generation of that. And then we have OLSR v2, which came from OLSR v1, which is a link state routing protocol, proactive. And then we have DLEP, which is Dynamic Link Exchange Protocol, which is the radio router interface that we've been designing. One quick thing. This happened between the last MANA meeting that we had and this one, is that AODV v2, which was progressing as the standard reactive protocol, was killed in the working group. It may live on in another iteration or somewhere else, but not as a working group draft. The working group couldn't come to consensus on the issues in the draft. So I wanted to mention that because some people might be interested. Okay, so packet building block. What are some of the features of it? Why did we want a standard approach? Some of the key features is it has packet type length value. It has message type length value. It has an address type length value. So you can extend these kind of protocols. You can add values to your message. You can add values to your addresses that you're including in your message. And you can add TLVs to your packets. You can have multiple messages from different protocols in the same packet. This is important because when you're operating in these environments, you want to send as few packets as possible. So you want to put your various messages together and send them back out. And you can also have multiple messages from the same protocol, like when you're sending topology control messages or link state messages, and you want to concat them from different sources, you can do that and rebroadcast it out in a single packet. And the other thing it does quite nicely is it does address compression. Stan was saying how the address assignment is kind of a tricky thing in MANA, but a lot of the MANAs that are deployed have similar address spaces, so it's kind of redundant to send the whole, 64 bits subnet for every address. So it compresses it automatically for us. Here is a breakout of all of the fields. This is packet BB in its entirety. The colors might be a little hard to see. The blues are the things that are required, and at every level, it breaks it down further. The dark greens you can have multiples of, and the greens you can have one of or zero. So a little bit more concise. And to reiterate, you have the packet, you have a header that can have some TLVs in it, some information in the header. You can have multiple messages, and they can have, each message can have values associated with it, like a time value, a validity time, or a signature. You can put signatures in the messages as well. And then each address can have a TLV associated with it. And the way the TLVs for the addresses work is you can have a single TLV that indexes multiple addresses, so you get some compression there as well. And here's a very simple empty message. This could be something as simple as a hello, an empty hello message that's being sent out by a protocol that is not defined, but you can have a very short message. Neighborhood Discovery Protocol. It's called Neighborhood. We did look at other protocols that would discover neighbors, but for OLSR v2 and algorithms related to our multicast forwarding, we needed 2-hop neighbor information. So we designed NHDP. And it's a hello protocol, and some of the key features, it discovers 1 and 2-hop neighbors, and that's very important. It discovers symmetry. It has dynamic timers, so you can slow down or you can speed up depending on what your network is doing at the time. And those timers are also distance-based. So you can send out a message that is valid the further away it gets. That's not necessarily important for NHTTP, but the timer TLV that we defined, I'll get to that later. I'm jumping ahead of myself here. But for NHTTP, the dynamic timers can slow down if you're in a more stable network with some extensions that people have proposed and I've actually implemented. And it provides an information base and an organizational structure to keep those neighbor states and link state information regarding the machine you're on. And this is useful for things like DLEP, the Dynamic Link Exchange Protocol, the radio-to-router interface, can write to that table, and there are rules in NHTTP about what's allowed and what's not allowed regarding link state from outside of just this protocol. So that table can be accessed both to write and to read. OLSR uses this V2 to generate its link state information. I'm going to go over these really quick. These are actually generated from the appendix in the NHTTP document, so if you want to go over them, and there's more text regarding this. But NHTTP also supports multiple interfaces. And on the left, you're going to see the physical network topology, and those lines at the top, those are wireless links. Those are links that NHTTP has decreed to be connected or symmetrical. And NHTTP goes into details on how it does that. In the curly brackets are the interfaces, and the blue boxes are different nodes or routers. So very simple. And on the right, you're going to get what NHTTP will present to you as you're using it. Relatively straightforward. It supports multiple addresses on the same interface, illustrating here. On this one, you can see that it provides 2-hop neighbor information, but it doesn't know that interface 3 and interface 4 are on the same machine. NHTTP, as is, they're 2 different addresses, and you don't know that they're connected. Again, just another example. In this case, it knows that 2 can get to 3, and that it can get to 4 some other way. It doesn't know how it can get there, but it knows it can get there. It can get to 2, and the node that is 2 also has an address 5, and it can get to an address 4, but it doesn't know how. And these are examples to show how it works. In this case, you're going to have 2 entries, 2 tables, one for each interface, about what your network looks like. So you get kind of the same picture done twice. And that's kind of how NHTTP presents the neighbor table to the user once you have NHTTP running. Again, these are in the appendix of the NHTTP draft, and there's more text describing why it works the way it does. And you can get more complicated. When you're running, and this is just nodes running 2 interfaces that are dual homed interfaces. NHTTP, I've run it up to, in my emulations, up to 90 nodes, dual interface, moving around. The tables get enormous, but it works, and it's kind of fun to watch. So simplified multicast forwarding. This is what we've designed to take care of multicast forwarding in mayonnaise. Some of the key features is it does network-wide flooding. It doesn't flood. It's not tree-based. It is mesh-based, so it takes advantage of NHTTP if it's there. It actually doesn't need any other control protocol. It can do classical flooding where every node in the mayonnaise sends out every multicast packet one time. It's kind of ugly, but it's standardized and it works. You can reduce using NHTTP and the algorithms in the back of the appendix of SMF. You can reduce the flooding based upon a connected dominating set that you calculate using NHTTP and the algorithms. And TLV types that were defined in SMF allow you to do that, piggybacking on the NHTTP. And there are rules for duplicate packet detection. And since this is an experimental RFC, there are a couple that are kind of a no-no, like using the reserve field in the IPv4 header as an ID field. And there's also hash-based algorithms to detect duplicates. We found that with hash-based, it really depends on your source traffic. Some sources will get lots of false positives and you'll end up dropping packets that are kind of important, such as heartbeats and blank frames. So it depends on your traffic that you're sourcing in your network and what approach you want to use. The other thing that's negative with hash-based is depending on your devices and your hash algorithm, you can kill the battery real quick. I'm going to go over these really quick. I left these in here more for illustrative purposes for people later to go over the algorithms. These are all defined in the back of the SMF draft, and they're illustrated here to show how the CDS algorithms work, connected dominating set algorithms. Let you guys read that real quick. And I'm going to step through it. So an example from one, NHTP does its discovery, and that's what you see from node 1. You don't know about the rest of the network, but this is what you know from NHTP. We're using the router ID as the router priority in terms of forwarding. So you look at this is just an algorithm that calculates the ECDS. Starting with the greatest one hot neighbor, you visit all of his neighbors, and if their priorities are greater than you assume they're going to flood, and you keep doing it. Well, we didn't cover everyone, so we have to turn ourselves on. And then we will that node will inform its SMF forwarding instance to rebroadcast all multicast packets. And you do that for all the nodes in the network. Everyone does it locally. They're only using 2-hop neighbor information. You're not sending around full network topologies in this instance. And these are the nodes that we're going to flood using the ECDS algorithm. And that's, I believe it's essential connected dominating set. Another algorithm is SMPR, which is the source-based multi-point relay. It's the multi-point relay algorithm is defined in OLSR and OLSR v2, and also in the back of the SMF draft. And the way it works is again, you get your neighborhood from NHTP. This is what we know about. You pick nodes that you have to because they're the only way to get to them. So 7's picked because that's the only way to get to 11. We have to pick 15 because it's the only way to get to 3. We have to pick 13 because it's the only way to get to them. And then we inform the neighbors who we selected. So this is done by adding a TLV to the NHTP messages, by adding TLVs attached to those addresses that we want to say, you are now my TLV. So in the NHTP block, the NHTP address block, it has all the addresses already from exchanging neighborhood information. We're attaching this extra TLV that says, you're now forwarding for me for SMF. Everyone does that, so we get this. And then when a message is sent out, the SMF algorithm works in a way. In this case, 15 didn't forward because 4 informed 15 that he was not required. And the first time they get the message, it blocks all other forwarding messages. So even though 3 informed 15 to forward, 15 already knows he is not required. So in this case, that would be our forwarding tree when sourced from 4. The unique thing about the SMPR algorithm is that it provides shortest hop paths, and there is not a single tree for all sources. Different sources have different trees that get populated through the network. And then there's the MPR CDS algorithm. It's very similar to the MPR one, except it ends up down selecting to a single tree. And I'll just skip over this one, but this is the resultant CDS for this algorithm. So OLSR v2 is our working group's standardized proactive routing protocol. It's built on NHTP. It uses 2-hop information. It augments NHTP with TLVs. And the main one it does is that it attaches NPR information so that it uses the same algorithm I described above, but instead of using it to forward multicast messages, it uses it to rebroadcast or resend TC messages, which are topology control messages. It supports detached networks, including default gateways. It does dynamic timers. I was talking about dynamic timers in NHTP. The dynamic timers are also distance-based, so the further a TC message gets away, can have a different validity time. And that's important for doing things such as hazy-sighted routing or fisheye routing. So they're both supported with the timers that are available. And metric support in OLSR v1, and actually all of the original routing protocols that we've designed as experimental, they didn't have any support for metrics, and that was very important to have support for metrics. In the deployed networks that people went out and did, myself included, we came back and said, hop count is kind of not good. Doesn't work. Doesn't work well, depending on your network. The problem with hop count is that you end up picking the neighbors that can get to the most neighbors, and they're the ones that are the furthest away, and they're the ones that have the worst links. So you really don't want to always use those, depending on your underlying radio technology, of course. So metrics was built in to OLSR v2. Now the type of metric depends on what your radio does. OLSR v2 describes an additive metric that is unitless. So you can use whatever you want. What's optimized about OLSR? There are 3 ways it optimizes traffic. It reduces the number of routers sourcing a TC. So not all routers in the network need to send out their link state information. Only routers who have been selected to forward TC messages and have been selected as multi-point relays send out link state information. So a subset of the nodes send out link state information. Those nodes only send out link state information about who has selected them. So the next slide, I'll demonstrate this. And the reduction in the number of TCs. So the same way SMF reduces the number of floods, OLSR uses the same method. So I'm going to go back to my handy-dandy picture. NPR selection happens. Those nodes do not source TC messages. They're not anyone's last hop, so they don't send out any routing information other than participating in the NHTP and neighborhood discovery protocol. 15 isn't going to send out his link to 4 because it's not required. 15 is not needed to get to 4 any route. No one needs him. No one needs the link from 15 to 4 because there's another way to get there. So that link is not advertised by default in OLSR v2. And these are when it is forwarded from 4, these are the only nodes that are forwarded. So that's how OLSR is optimized. The timers can optimize it further. And one other thing is because it's using the packet BB format, the TC messages don't need to be their own packets. You can concatenate messages together into a single packet so that you delay the time that you send it out by some microseconds, and you concatenate multiple TC messages together. This is an illustration of my code that I've built and how I conceptualize it in my head. You don't need, another thing that works with the framework we've built is you don't need OLSR to be running on all your interfaces. You don't need NHTP to be running on all of your interfaces. You can have some just doing multicast, and you can do others doing unicast, and it will work. So this is illustrating that fact. We also have MIBs designed for OLSR, SMF, and NHTP, so they're available as well, and there are MIB interfaces there. And that's that. I'm not showing it here, but I do have, anybody interested in code, I have open source code. We have open source code. olsr.org is a really good site for getting open source code as well. They give it away freely. And it's not just OLSR. They do NHDP. You can run it as NHDP as well. NRL, my company, has SMF implementation, NHDP, OLSR, and OLSR v2, and they're open source as well. So if you're interested in those, you can come to me and talk to me after. And then that's kind of where we're at today. I don't know if I want to say one more thing. At the MANA meeting tomorrow, if you are interested in any of this, please come. I think we've designed a framework that allows itself to be extended in multiple ways. And having just one standard protocol right now is kind of frustrating because we put a lot of work into the framework and the building blocks of building this up. And having these separate pieces is kind of silly if there's only one protocol using it. And there are advantages to having other protocols use some of the pieces of the framework, such as we have signature-based TLVs that allow you to sign your message, and we have validity TLVs that allow you to ensure the integrity of your message it's safe. So there are people put lots of hard work into getting those through, and there's really value in them.
Okay, last thing on our presentation for today is DLEP, the Dynamic Link Exchange Protocol. And DLEP has cleared working group last call. We're in AD review with it right now. So what is it? It's a way for radios and routers to communicate information to each other. It allows the radio, for instance, to communicate the characteristics of that variable quality RF link. Routers can also ask the radio for a specific transmission profile. Can you give me, in the satellite case, for instance, can you give me more bandwidth? Can you give me better latency? Those types of things. And by and large, DLEP specifies the what. It specifies what data items, what requests can be made across a chasm between router and radio, but it doesn't specify how a specific piece of information is used. So what is it as we keep going forward? Again, these MANAs need to handle rapid topology changes. They need to handle rapid link quality changes. And in this kind of an environment, relying completely and totally on dedicated timers running at layer 3 for like hello and dead timers, it becomes problematic very quickly. For instance, in that disaster recovery case I was talking earlier where you have the fire brigades, if you suddenly see an aircraft overhead that's using a common radio, you can turn a 4 or a 5 or a 6 hop network into a 2 hop network or a 1 hop network very quickly because you can bounce off the aircraft, but not while you're waiting for a hello timer to pop. So what DLEP allows the radio to do is to tell the router, I see somebody new on the RF network. You probably need to go issue a hello message, reconverge the network. And it will also continually tell, it allows the radio to continually tell the router, my transmission characteristics are changed. You know, the radio's either faded because of obstructions or multipath interference, or it's gotten stronger because of mobility. And the last slide, I promise, over what is DLEP, is that it is a one-hop only protocol. The notion here is that the router and the radios are usually connected via Ethernet. You take a radio, you put it in the vehicle. You take a router, you put it in the vehicle. There's a short Ethernet connection between the two. We use GTSM and explicit settings on TTL values to make sure that everything occurs on just one layer 2 domain. There's no over-the-air signaling. Nothing in DLEP, nothing specified in DLEP actually goes over the air. It's all between the local router radio pair. But we do infer, we imply that there's some proprietary OTA signaling going on because the radios actually know about each other, and they may have exchanged information in a proprietary way in order to communicate it to us. And again, here's the slide talking about that UAV that would appear, or the airplane that would appear, using multiple radio types in order to cover a broad-based area, and doing that with continual updates on link status so that routers can do things like recompute cost metrics based on the bandwidth, the delay that fluctuates real time. So that's pretty much it.
We do have some time, about 5 minutes for questions, if anyone has questions. So now you know everything there is to know about Mene, almost. As Justin mentioned, tomorrow at 2 o'clock in somewhere, I don't know, is the Mene working group. I mentioned before we just rechartered the working group. So it's a whole new charter, whole new work items. All of you can come in with all the knowledge you know now and contribute to the Mene working group.
I would actually, we forgot to include the work items on our presentation, but real quickly, we're chartered to do a Mene management document. So how Manes are deployed and managed, we're chartered to do that. Lots of people have been asking about, well, what are Mene networks? And this is kind of going to be the draft that addresses that a little bit. We're rechartered to do, like I said earlier on, the multicast work. We want to do a building block approach. So I'm going to have a presentation on how we want to design a forwarding information base. And then DLEP extensions are extensions for more metric types, and just other extensions for OLSR and other protocols that might want to come along. So please show up.
Earlier in your talk, you said something about building large packets by putting multiple packets together. In this environment, it would seem that a large packet has a much higher chance of getting hit by an error than a small packet. And I was wondering whether you chop things up and send them in chunks, or if you use heavyweight for the error correction, or you just change the speed on the link to make sure that your error rate becomes acceptable.
A lot of that depends on the radio you're using. We have found that smaller packet, and we've done this through experiments, we found that smaller packets have a higher chance of getting through a lot of the time. And that's not always good, because then you know about neighbors that you really don't have a good link to when you're sending out hello messages, because now I'm sending a large data flow using full frame packets, and it dies when
No, I was thinking about the ones that actually carry
right. It works both ways though. So you can actually pad out the messages to make them larger, or you can chunk them up to make them smaller. You don't have to include multiple messages in the same TC. And the NHTTP protocol and the OLSR protocol actually allow you to separate the addresses out into multiple messages if they don't fit, or if there's some reason to have multiple messages for one, it's the same message, it's just put into two different messages, and those protocols support that.
Okay, thank you.
Maybe you could just explain simply why the 2-hop neighbor is important in this case, because I think I might understand, but.
So if you go and look at the slides and the animations on the algorithms, a lot of the algorithms require you to know who your 2-hop neighbors are to select a subset of them to calculate the CDS algorithms.
Now,
the key is really the CDS algorithm.
Is CDS for like flooding the link state information?
That's what it's used in OLSR.
Okay.
V2 for and V1. And actually the ECDS algorithm was defined originally in the OSPF Mene extensions draft. So it's a different algorithm that achieves somewhat similar behavior.
So like in ISIS or OSPF, we can be sort of liberal in flooding out every link, and
right.
Whereas here you say, well, we've got to be more conservative about how we use these links. So let's look one step ahead.
Yeah.
Is that?
Yes, you're absolutely correct. There is also I believe it's experimental, draft 5820, RC 5820 uses a two-hop neighborhood flooding inside of OSPF v3. So you can use it in wired links as well. It'll bring your overall control plane traffic down some.
The OSPF extensions for MANA extensions do the CDS stuff, but they don't. They get you part of the way there. The other parts are the reduced number of link state advertisements in OLSRv2, the dynamic timers, the faster timers, that sort of thing. But it does get you to something that will actually work.
Great, thank you very much, guys. So, again, one more question? Okay, one more question.
Yeah, I was wondering about DLAP. Do you see that replacing the hello messages in OLSR and other protocols?
I see it augmenting it. Right now, without further extensions to DLAP, it does not give you two-hop neighbor information. And it also doesn't allow you to there are TLVs attached to the hello messages that signify you're willing to route or you're willing to send multicast data. You're an SMF node. So not completely. It's more of a trigger to trigger something to happen and better update the one-hop neighbor table with better link state information.
So thank you again. So now on a related topic, we're going to have Ross talking about simplicity or complexity in protocol design. Yep, you can use the mic over there. And you want
Thank you. I'm going to up the mic a little bit to make it Ross sized. I'm going to talk about the cost of having too much complexity in our standards, and I don't really mean too much complexity in one standard. I mean sort of across the whole protocol suite. I want to emphasize up front that the ideas expressed here are my ideas. I haven't gotten anybody to say it's okay to give the talk. I'm just giving my own ideas. Since you all know I'm retiring in a few weeks, it's too late for anybody to fire me if they don't agree. I thought before I retire, I'd talk about one thing I'm a little bit concerned about, which is I actually think we're making things too complex. And, when I mean well, maybe the laws are too complex in many countries and the tax laws are too complex. There's a lot of stuff that's too complex out there. That seems to be the way people want to go. We can't control all of that. We can control what's done here in the IETF. And I think here in the IETF, we're also making our protocol suites too complex. We're seeing multiple options. We're seeing more and more options added to a lot of our protocols. We're seeing multiple ways, in some cases, to do essentially the same thing. Now, some diversity in approaches is inevitable, and some diversity in approaches is desirable. But we sort of have to keep it to a dull roar and be concerned about basically invalidating the value of standards by having too many of them. I'm going to talk about one particular example. It's just one example because, frankly, it was the easiest one for me to come up with. There's lots and lots of examples that I could have come up with. I just picked one that was sort of, obvious. Particularly in the case of VPNs and in the case of encapsulations, right? In many cases, VPNs, especially layer 3 VPNs, well, probably layer 2 also, support private addresses. So the same address space, net 10 can be used in every private network all around the world. You pretty much have to use encapsulation. I did, after too many beers, think of another way to do it without encapsulation, but it's so ugly nobody in their right mind would ever do it. So practically you need to do encapsulation of some sort. We've come up with several ways to do it. One way, which is basically based on connection oriented, is use MPLS. And you take your private packet, whatever it is, wrap it up in an MPLS label, send it across your network that's supporting the VPNs and deliver it at the other end. We got 3 control planes that all, you know, 3 you might say to you, could we have done with 1 or 2, but 3 is still a sort of acceptable number. I think there's some differences in terms of what it really means to have a label assigned with each of the 3 methods, so it's not too bad. We have a couple of protocols with OAM that are really complementary. Because there's basically 1 data plane, it's been implemented, and everybody's implemented, and all the data planes work together, and it works just fine. Now, in principle, you could just as well support VPNs in a connectionless environment. You don't need to set up a connection to support a VPN. And we have ways to do it. You could use IP in IP encapsulation. Now, of course, that really is not, you know, it looks like one approach. In some sense, it's almost 4 approaches, because you could use IPv4 encapsulated in IPv4. You could encapsulate IPv4 in IPv6. You could encapsulate IPv6 in IPv4, or IPv6 in IPv6. So at least in terms of implementing a data plane, there's 4 different things you can implement there. You could put UDP in the middle. So, you know, IP and UDP and IP, 4 more options. You could put GRE in the middle. You could encapsulate your GRE in UDP, in IP. You could use L2TP. You could use IPsec. There's lots and lots of options. The problem is there's so many of them, you can't really get one of them ubiquitously deployed. So most VPNs use MPLS. People want to send MPLS, you know, your VPN packets across a backbone that doesn't support connections. So you encapsulate MPLS in IP. So that's another way to do it. Now the problem is you got, you know, routers or switches in the middle that cannot look inside an IP packet to hash on an MPLS header. And because you've got a, you know, tunnel from a big switch to a big switch, there's a lot of traffic going between one ingress and one egress. So you want to split that, load split it across multiple paths. So why not put MPLS in UDP in IP? I actually missed one out. There apparently is also a proposal for MPLS in GRE in UDP in IP. And there's VXLAN, and there's Lisp, and I think people are working on other options too. Now, it looks like there's only 10 options there, but in fact, since IP and IP is really 4 instead of 1, there's probably more like 20 or 30 or 40 ways that we could send VPN traffic across a network without setting up connections. The problem is when you have 20 or 30 or 40 ways, some vendors implement some of them, some vendors implement others of them. Different stuff gets deployed in different places, and you basically don't have a standard. What you have is no standards at all. Lack of interoperability. So why does that matter? So I'm now stepping back and looking at things from a different perspective. Right? It's been said that the internet is the largest machine that has ever been built. There's billions of computers, billions of users all over the world. Something like half of the human race is now attached to the internet. When I started on this, the number of users and the amount of bandwidth was doubling at least every 6 months. At this point, it's too late to double too many more times the numbers of users because we've already got half of humanity, right? We can only sort of get all of humanity, so we can double one more time there. But we're still increasing in terms of the amount of bandwidth and the number of uses. Last Friday of last week, I got on an airplane and flew here, right? A lot of you guys probably did too, whether it was Friday or Saturday or Thursday. The day before I left to come here on Thursday evening, I went with my family to an ice cream place right near where we live. And it's a pretty good place, and they got like huge numbers of flavors of ice cream, and they have a putting green, and they have a driving range, and they have tents where corporations can have, you know, lunches on special events. And so they got lots of space. And for the first time when we showed up, what I found was they were mostly teenagers, but a few kids and a few adults running all around the place with, you know, their smartphones catching Pokemons. And you know, it was like all over. And you know, my daughter, who's about 20 years old and looks a bit like Maria Sharapova, was off talking to some, you know, teenage guys about where the best Pokemons were. And then, you know, my other daughter and her then rushing off to wherever the best Pokemons were. And it was really quite exciting. So the first thing I thought was, you know, this is cool. But the next thing I thought is, how did we ever come up with this, right? What had to be done to make this thing happen? And, you First there's of course the internet with high-speed bandwidth and big links and stuff, and then there was the wireless technology to allow the internet to be available everywhere with handheld devices. Somebody had to build those handheld devices, with a video on one side and a phone on the other side and high-speed access and a good computer in there. And then somebody else or some other company came up with this idea of having wild Pokemons all around the world, wandering around, and then having people all around the world chasing all the Pokemons. Probably somebody had to figure out how not to have Pokemons in places where it's actually dangerous for teenagers to go. So I'm hoping somebody figured that part out. In this particular case, the ice cream place was very safe, so I wasn't worried about my daughter rushing off to, or my two daughters rushing off to catch Pokemons. No one vendor could ever have done this. No one vendor could even have thought of it, right? Especially when you add in things like, Craigslist. The next time you buy a bicycle or a kayak, you probably go on Craigslist and get it used, which means that places that sell used bicycles, I've been told by people who used to sell used bicycles that they can't do business anymore because they just can't compete with Craigslist, right? You want to buy a book, you go to Amazon. We've completely revolutionized the world. You come here, obviously, you look at maps and, figure out that the overflow hotels, how far away and where the restaurants are and stuff. So we've completely revolutionized the world, and no one vendor could ever have thought of it. No one service provider could ever have thought of this, never mind done it. So the internet exists because of multi-vendor and multi-service provider interoperability. This requires real and effective standards. It requires one or maybe 2 or 3 ways to do things, not 20 or 30 ways to do the same thing. Now, you could think about the financial part of all this, right? This internet that we've all built is, I think, enriched all of our lives in a great way. It's improved the information available to it. It's improved communication on a worldwide basis. Clearly, the world's got enough problems that it's a good thing that we've improved information and communication because we're going to need it. But it's also made a lot of money. And it's made money for individuals, so sometimes some of us can actually afford to retire eventually. It's also made money for companies. So the amount of company, we all have a company, or most of us have a company that's paid for us to come here. The amount of money that our company makes because we have real effective standards, because the internet can explode like this and become huge, is far greater than the amount of money our company is going to make by winning one particular battle or coming up with yet another option for a protocol suite. This great financial success that we have called the internet exists because of effective standards. So it's really up to all of us to protect that and to make the standards continue to succeed and be effective. What about private networks, right? Do private networks need standards? After all, they just sort of stand on their own. Well, private networks and data centers have been revolutionized by internet standards, by internet technology, I should say, right? Because if you build one router of a different type, it's really expensive. We used to do that, for the government would get a vendor to build something special for a particular network somewhere. Now, it's all IP stuff because there's so many IP routers out there that the cost and performance has been driven to high performance at a much lower cost per bit per second than it used to be. Now, of course, the bits per second go way up explosively and the cost per bit per second probably goes down slower, so the cost per cubic foot might go up, but the cost per bit per second has gotten tremendous. So, these standards are not just useful for the internet, they're useful for private networks, they're useful anywhere where you do networking. So I'm sort of going to give them a call for action and then sort of run away and leave, and you guys are going to have to do it without me, I guess. But I think the IETF needs to find a way to avoid excessive frivolous standards. I don't think that this can come from the IESG for several reasons. One is, if we have a working group full of hundreds of people and we're all agreed we're going to progress something, who's 180 to stand in the way and say, no, you can't do that? The other reason is, if you look at this room and then you go to the plenary tomorrow and you look at all the people there, the total brain power in that room is enormous, right? If Albert Einstein were here, he would say, oh my God, I cannot possibly hold as much information in my head as all those guys have in their head. Nobody could. So And also, when you look at places where you have, 5 or 8 or 12, or in case of datagram encapsulations, 20 or 30 standards, one person just has a terrible time holding that all in their head. So in order for us to, plus of course, to try to figure out which standard to not do is a really hard job. And it's probably harder than coming up with a standard to do. So really, we've all got to do this, right? Everybody coming to the IETF has got to think, how do I make, well, at some level, we got to say, how do we make money for our company? Because, making money for our company is why we're paid to come here. But we do that by making the internet successful. How do we make the internet successful? By making standards effort successful. And that means trying to spend the effort to, try to reduce the number of standards whenever we can. And I think it's going to be, hard to do that, but I think it's important. So that was sort of my point.
Perfect. Yes. Thank you, Ross. Any comments, Justin?
Yeah, I'll wait here and see if there's questions.
You have a document?
No. I was thinking of coming up with a standard way to reduce the number of standards, but I can only think of like 5 ways, and I wasn't sure which one to progress. Yes, if people want to read RFC 1925, it was published on April 1st, but it is entirely true. Yes.
No, I don't think so. Charlie, the one in the back. The one in the back is on.
How's that? Better? Yeah. So I think it's going to get a whole lot worse really fast because there's Internet of Things happening. And judging from what I saw in the low power wide area network buff, it just, it doesn't seem to be recognized the need for interoperability. And yet we're talking, people are saying 50 billion devices within the next 6 years or something like that. Well, 50 billion, that combinatorial explosion of things that can possibly go wrong with that is really amazing. So I don't know, how can IETF actually make a concerted effort? Because when you talk about reducing the number of protocols, you're also talking about reducing the number of validations of interesting ideas that people come up with.
This is a very tall microphone. Hi, I'm Kathy Aronson. I really like your talk. I think it should be like a plenary thing. But I just wanted to ask you, since you were at IETF 1, if you imagined at IETF 1 that your kids would be chasing Pokemons around on their phones.
Not at all. Yeah, thank you. Thank you, everybody.
Thank you, Russ. So before we go on to the next one, I just want to second, and I'm sure third and fourth, Ross's call to action, which is we are all the IETF, right? We are all the internet. We are the ones building that. We are the ones who have to think about that 27th option to do something. Do we really need that? Can we simplify it? Can we go another way? Can we use the building blocks that, for example, the M&A guys have built? All these things are important things to consider so that we can get to the next 95 IETFs. Now we're going to have Christian and Kathleen talk about code match. And I have a clicker for you.
So I'll just start with the overview in the interest of your time. Code match, how many people are familiar with it? Crickets. But that's fine because we're about to launch, so you didn't know how long it took us. So a few years ago at the Grace Hopper celebration, it's a conference for young women, primarily men do attend it as well, in computing. So a lot of students, professors. I went with ISOC to represent the IETF and got to talk to literally hundreds of students and professors. Out of that, the code match idea was began, right? So it is a way to just match up your standards with implementations. It doesn't have to be implementations by students, but then the initial idea was opening it up so that students would understand that they don't have to code throwaway things. They could code some IETF standards. It's not that simple though, right? Because there's so many RFCs and drafts. Where do you begin? So code match would, let's say I've implemented, let's say I've written a draft, and let's say Aaliyah has implemented it and she's interested in seeing more implementations of that draft. So she might post within code match that she, first of all, has that match between a standard or a draft and connecting it to code somewhere, whether it's proprietary, open source, or maybe she's actually mentoring a student who's doing this, right? So it's a student doing it open source. But then she might also say, I'm willing to be a mentor because I'd like to see additional implementations of this draft. So she would sign herself up to be a mentor, which means that she's on the hook to answer questions from other implementers about the draft so that they get them in a timely fashion. And we needed that for students to be able to implement these drafts, right? So you'll give some kind of estimate in terms of time, or we're going to leave a description field so that you could put in how many message flows or some other way to try to assess, because it's really hard to assess how long it will take to code something. But that's also important for a student. They might search on something they can get done within a particular time frame. So this mentor ability, understanding how long it takes to code. And the goal would be to have a better representation of how many implementations we have of drafts and standards. We'd show better connections between open source and standards, which would be nice to see because there is quite a nice connection between them, and to have a very demonstrable way of showing it would be helpful, I think. And so we've had a team from Brazil working with us coding this for a little over a year or so now. There was a lot of upfront work planning. It's not perfect yet, but we're ready to release, and that's why Christian's going to give a little bit of an overview, asking for some help for initial testers and people who can be helpful and give us feedback. How do we improve the site? And also keep in mind that we have this as just our version 1 release, right? So we have additional features planned that haven't been implemented, and we would actually welcome additional coders to help to get those done. So without further ado, Christian?
Sure.
I have to get back to AD in other sessions, so I may just split, so sorry.
Thank you. So this is going to be quick. So yes, basically it's a tool that it's already online. It helps the authors to offer their proposals, to engage researchers, professors. So from one side, it's going to help the authors getting their proposals implemented. And on the other side, for us that we are trying to engage more people on the IETF, so it's easy through these coding opportunities to engage students in less engaged regions, I would say, like Latin America, that's where I'm coming from, but also from other regions. So we will show them opportunities to do work for the IETF without going deep in the IETF process of creating standards or reviewing or things like that. It's like an initial step for them. So the tool is online. It is a data tracker application, but it's not inside data tracker. So we didn't want to announce it broadly to the whole IETF community because we do not know how is it going to perform. So we prefer to have like a selected group of people like you on the Rtgarea to be our initial authors using the tool. And basically, this is what you're going to see. It has a different look and feel, but it's based on data tracker. The look and feel is different because initially we thought that students were going to be more engaged with a easier look and feel. I don't know if it's going to be the case. Probably in the future, it's going to inherit all the look and feel from Data Tracker. But anyway, this is what you are going to see. Oh, I forgot to include. You can use that URL right now from your computer. This is not an official IETF tool. It's not supported by the tools team. It's an application that it's supported by a group in Brazil and a developers group. So it's not an IETF.org tool. You can go online now, check that, and you'll see that page. So you've got code matches that are the association between a code request and actually it's the association between an implementation, a code, like a GitHub repository or something, a URL that it's going to link to a real code, and the drafts that that code is currently using. So for example, if you're an author, you will go to code requests. You can see all the code requests that you or anyone else have entered. You can create a new code request, so you will be offered, you can type a title, a description. That description will let you sell or tell others what you want from your proposal. So please try to do that description thinking on a student or a professor or a researcher, someone that with that description is going to realize that that's something that it's worth working on. A protocol, you can be the mentor if you're the author and you are looking for someone to implement your proposal. You can be the mentor, or you can appoint someone else as a mentor. The mentors are people that are already registered in Data Tracker. You have to log in here. You will use your login credentials from Data Tracker, your current user and password. You have to log in again here because, as I said, it's a different server. Well, there's a field for the amount of work that this implementation might require, like a couple of hours or a couple of years if it's something very difficult. So the student or the professor can have an idea of if this is a work for a class, a project for a class, or a project for a research. So it's a way to describe how big the task is going to be. And here and there, the drafts or the documents that you are going to, or that this implementation should implement, should use. So you can there include any document that it's currently included in Data Tracker, drafts, RCs, whatever. So then on code requests, you'll see a list of all the requests that were entered, and there's a link for an association. So you can associate a software, a program, something that it's already developed with that request. So when you start creating those associations, are called code matches, you'll see a list of those associations underneath the code request. So when you click on the associate my project, that it's on the upper right hand, so you'll see the name of the code request, the description, and then you can type the URL where this code is located. You've got tags for searches in almost all the records that are created. And then you will see all the code matches between the requests and the projects that implement those requests. You can also, or we can also create code matches even though there's no request. For example, an author did not enter his request, but a developer implemented something. He can create a code match himself without the need of the author being involved. And he can reference which documents he used for his code. So it's going to help us documenting all the open source or developments that have been done based on IETF documents. And well, when he creates the code match, same thing. He will use the description for what he has implemented and the documents, all the documents that he used for his code. So how can you help? You can enter your requests, or you can enter your code matches if you have developed something based on IETF documents, and provide feedback for the code match team so we can tune the application. Nowadays, we are not ready for an open announcement. We are not going to send an email to the attendees or IETF list. So we want just you to be using it. The other one.
Hi, Rick Taylor. Just a quick question about your licensing intentions on this. I get the feeling that you're looking for open source software, so you're talking BSD or GPL style. Have you got licensing policies set up, or are you more deferring that to, well, if you're using GitHub, then please use a license that they like? Has that question got an answer?
It's not a requirement to have open or to be open source. So it could be licensed. There's no information here about the license, but when you see the list of documents, those are clickable. So you can reach the document, and from there, the IPR that is associated with the document.
I understand the IPR requirements on the documents, because that's covered under the Notewell and the standard IETF. It's the implementation.
Yes, the code itself.
So if I can interrupt a second, Kathleen asked me to pass on that she forgot to mention that this is absolutely, you can enter proprietary implementations. You can be matched against drafts or RFCs as well, not just for code. So you can use it to help organize, say, plug fests in the future or notify an errata. It's not just for open source.
Okay, thank you.
Thank you.
Sandy Murphy, Parsons. So the IETF and the routing area in particular have an interest in interoperable implementations. And it's usually phrased as two independent interoperable implementations. The idea is that from a quality of the standard aspect, having two people who independently were able to read the standard and come up with something that interoperates, it's a good thing. If you've got the same mentor mentoring two implementations, answering the questions from that mentor's understanding, how does that play into the independence of the interoperable implementation?
So I'll take that question. Maybe you want that. I recently had a conversation with actually John and Sue, the chairs of IDR. So IDR is famous around the world for requiring two interoperable implementations. It is, well, whatever. So we were talking about that precisely, because not all implementations are the same. If we're talking, for example, about BGP, the BGP that I have in my laptop right now is probably not going to get deployed in the backbone of the internet. And as much as it does interoperate with a Cisco router, for example, it shouldn't count. So one of the things that we talked about is that that's the reason why we pay all you guys chairs the big bucks, right? So that you can use your discretion and make those decisions. So what we hope, or what I hope, one of the reasons I like CodeMatch is because we'll be able to get other people reading the specs, other people implementing them. Sure, interoperability, maybe we'll find bugs, maybe we'll find enhancements, maybe we'll find other people to contribute to the IETF, et cetera. But these, unless they become, I don't know, a shipping software somewhere, they probably wouldn't be the ones you count as interoperable implementations. Kristen talked a lot about targeting schools and professors and, et cetera.
Right.
Right, so we need to keep all those things in mind when making the decisions, your decisions, right, as working group chairs, as to whether it met that bar of the interoperable implementation who want to see to certify that this software should, or that this specification should go forward, if you have the requirement, correct?
Okay, thank you.
Thank you. So, Kristen, just one question. Just to make sure, the system is live Because Kathleen said before that, we want to test this. No, we want people to start putting real code matches in there. Right, so this is things that you would like to see coded. You, as working with participants, as chairs, as you can tell your working groups, so that people put things in there and we can start using it. We thought that we do so many good things in the routing area that this would be a good first step. This also gives us the opportunity to sort of corner the market. Right? There's people sort of waiting for this. If all they see is routing stuff, well, they're all going to do routing stuff. They're not going to go do anything else. So it's open right now. In exactly 35 minutes, you're free to go and fill everything out. 35 minutes when the meeting ends, right? Not the website is up right now. So any other questions for Christian? Okay, thank you. Thank you. Yes. So now we're going to get to what everyone has been waiting, and hopefully not the only reason you've all are still here, which is the overview of all the working groups. Just so you remember, these are the working groups. At the top is us three over here, and these are the working groups we're responsible for. The one new working group that we have is Babel, and Aliyah is the responsible AD. Everything else didn't change from last time. So hopefully by now, all the chairs filled out the, and I can find it here, all the chairs filled out the wiki. If not, we're going to shame publicly the ones who didn't. All of you know the risks of not doing your job. Okay, so we're going to start. You know the drill. We have not a lot of time. Everyone can read. Probably if I make that bigger, it's better. But what we want is the chairs to come up and give an overview of their working group, what has happened. We can start. Go. Remember, the front microphone doesn't work.
Babel, new working group, first meeting Thursday afternoon, have three presentations, one on possible improvements in the current experimental RFC to get a standards track, one on an information model, and one on usage of Babel.
Bess.
So we are meeting on Thursday. We had 3 RFCs published since last IETF. We had quite a lot of drafts adopted, including 2 Yang drafts. So the work on Yang is ramping up, like in other working groups. Other things we can mention is that we have one document that's been kind of stalled at the stage of ISG reviews, and it's been returned to the working group, and we will have to decide what we want to do with it. We can observe a certain lack of energy to move it forward. So nothing unusual, but 2 other things. We have applied one implementation policy since January. So we have some idea now of how it works, and it seems to be a pretty positive experience, at least until now. And last thing we've been trying to do to manage the workload of the working group is to propose volunteers to raise their voice at working group last call time to volunteer as shepherds. And it's also a positive experience. We have had volunteers each time coming forward to help. That's it.
BFD. So Jeff stepped out. So the BFD working group is meeting on Friday. Probably the highlight that he wants to tell everyone is that we managed to publish all the seamless BFD drafts. These included 3 drafts from this working group, OSPF, everything else. Here he comes, Jeff. I'm filling for you. Great working group, Friday morning. That's it.
Yes, thank you for letting me have the working group that starts with B at the beginning of the list again. So BFD is meeting on Friday, as you mentioned. Status-wise, the nice thing is we've actually completed some work. We don't pop RFCs very often in BFD. We had basically a cluster for the seamless BFD feature, which is basically a stateless version of BFD, potentially useful for things like segment routing. The full list of RFCs is up there. In terms of active work that we'll be discussing this coming session, we'll be discussing potentially VXLAN, depending on whether the authors finish responding. There has been an update on the BFD Yang module. That is potentially of interest that people are following the Lime work, so please pay attention to both of those if you have some interest. There is also going to be presentations on BFD in an EVPN context and multi-chassis. Beyond that, we have sort of a small cluster of things tied to the BFD authentication feature. One is potentially doing faster authentication. A few of us actually met with people from the security area earlier this week to discuss whether it's a viable option. And we have enough of a go-ahead for that we will talk about taking that into the working group. The other one is a continuation of using BFD as a mechanism for probing the stability of a link. We do have two pieces of work that we're trying to figure out how to finish dispatching. We have an MPLS MIB, which is basically done, that nobody seems to be interested in, and we've been discussing dechartering it. Probably talk about that on Friday. And the last item is that we have a BFD multi-point feature, which is basically cooked at this point, is deployed at least in one vendor, and we have to figure out how to move people and motivate them to last call.
Beer.
Afternoon. This is Greg, representing the chairs. We met yesterday. Good progress moving along. We've got 4 drafts that now have been adopted. There's some good response on the list. I think we got some pretty solid participation in moving things forward. We've got a stack of drafts that are kind of ready for last call, but we're currently on the experimental track. And the feedback we've gotten from operators as well as vendors is they would like to see this technology progress to standards. We know that we've got some heavy lifting to get there, and I don't want to move these drafts forward until we make that determination. Otherwise, they're kind of stuck on the previous track. But Lee made it clear, I guess we can go to last call. We just set them within the working group themselves and just don't progress them to the queue. So that way, they're still active documents, but all the due diligence with the other groups will have been passed. An example, when there's modifications in various IGPs and BGP to kind of take the signaling requirements for beer into account, and to do that work with the other groups and have that work reviewed would help our case in moving this forward. We also have to get a doc in place that kind of justifies our track move to standards. With that comes, we need working code, right? We need some deployment out there, and we need some interop. And we're kind of in that stage right now, and that vendors just kind of nod. I think it's pretty much understood that work is taking place, but no one's going to admit it until the code's actually out there. So it's kind of it's a fun time to be involved in this right now, because it's what we have on the internet is we got IP forwarding, we've got MPLS forwarding, now we've got beer forwarding, right? It's that place in the hourglass to make a change, and it's really transformational in how we do a multi-point replication across networks. People often say, if we'd done this, I think if we were doing network-based replication before IP, like say in the 60s, this is what they would have done. I mean, bit forwarding has been around for a long time. It's never been applied to a network-wide scale before. And when the requirements came what Deering was doing is a layer 2 overlay on top of layer 3. Layer 3 was already dominant, so he had to make some modification to that. So the baggage we were stuck with, we're finally looking at getting away from it. I think that's why we've got such an interest through the community. It's not just the benefits that come with it, it's the contrast gain to the pain of the solutions we currently have. So in the charter, being experimental, we are chartered to do MPLS and CAP, and that was part of the original architecture that was there, and one more. So we had several drafts already submitted, looking at various other encapsulations, and we can't just bring them all into the work. We had a last half of the meeting yesterday, like for an hour, we had really a design team-like discussion. It was great. Kind of looking at what the use cases are that are currently being addressed by the current architecture, if there's gaps there. Some awareness was really made that it's not just about use cases, it's really those operational requirements. Example case being that like in segment routing, there's a MPLS solution, there's a V6 solution out there. And there are operational reasons why networks are deployed in certain ways as well as others, and they're not just use cases. So that open discussion really about, okay, how do we focus is where we're going forward. You know, clearly we're not going to make an entire new V4 solution out there. So if it's IP based, it's most likely V6. UDP could be one, VXLAN could be one. I think there's a generic encapsulation as well. And there's early discussion about a new ether type. Sounds good, but you know, that's another giant hurdle to cross. And the discussion really came around as to the MPLS. Well, there's two mechanisms here, right? There's encapsulation and then there's the encoding. And in MPLS, it's a bit of a hybrid in that the set ID is kind of carried as part of the label, but the beer header itself has all the forwarding information required. And you know, another encapsulation could just use the existing beer header. Some people are looking at maybe looking V6 where it's hybridization as well, where they're encoding the bits into the V6 address. And there's concerns about breaking V6 and opening the door for other brokenness to come in. So we have to be hyper aware of that and bring in the correct experts before we progress anything forward. But we've agreed to, just from a show of hands in the room, a lot of support for an interim meeting, for a dedicated design team, throw everyone in the same room for 2 or 3 days on a whiteboard and make us come to a consensus and move forward with a recommendation to the working group. Thanks.
Thanks, Kurt.
Probably late September, but it'll be on the list and announced.
Daniele Ceccarelli for SeaCamp. We will meet tomorrow in the afternoon. We have 12 new drafts since 200 drafts since last IETF, which is good. It means we are very much active. New topics: microwave, flexible Ethernet, young models for transport, path computation models, and so on and so forth. This is from one side good, but from the other side it requires a lot of coordination because there is a lot of overlap. And I would like to thank Ross for his wonderful speech. Probably we are the working group with the tighter interaction with other standardization bodies. We are facing issues with ONF, ITU, MEF, OIF, and so on. And this is one of the reasons why a couple of months ago we decided to start a design team for radio links. Kind of similar work was being carried on in the ONF, but not in the proper way, in our opinion. So this is why we tried to put together this design team, involve the people from the ONF, and put everything together and make it compatible with our models. We are similarly, in order to put some order in all those new drafts, we are planning to kick off another design team, this time for transport APIs. Again, having to deal with multiple standardization bodies. Short overview of the working group status. We have a new RFC since the last meeting. It's basically changing the allocation policies for one of the registry we use for OTN. We have one draft in the editor queue, which is heavily based on this RFC. And OSPF availability extensions in the ISG, it's being processed by the ISG, and we have one draft which will be submitted to the ISG for publication soon on flexible grids.
Okay, thanks, Daniel. On DetNet, neither of the chairs could be here, so I'll do a quick review. They met yesterday. They are very busy with their terminology and data plane alternatives. They actually had a design team to look at different data plane alternatives. And so they have their new working group documents on the problem statement, an updated one on use cases. And there you'll see the updated IDs. It's for the design team, the data plane alternatives to flesh that out. And then an architecture one.
Okay, I2RS. The important thing is that we're in the last call for the ephemeral state requirements. We got a hum that it was all doing well at the meeting on Monday at 1400. I think we were a little off on our time. And so if you have comments on it, please make comments. We worked and had some success at the hackathon, and you can read the rest of it. We may have a meeting tomorrow morning or later this week because we had such a great discussion on the ephemeral state requirements that we blew through all of our time. So if you're interested to talk about our models, because each of them have seen, the topology model is been deployed for the base in the L3 in the ODL work, and the RIB model was part of the hackathon. So we will be looking at that code match and trying to get a little code match for the filter-based RIB and some of the stuff. So if you have interest in the models, come and say yes tomorrow morning. John, do you want to do this one? Okay.
Okay, IDR met this morning in the smallest and farthest away room in the facility, as is our tradition. So it was a interesting and active session with, how can I even describe it? There was excellent operator engagement, was I think maybe the thing that actually stood out the most positively for me out of the meeting. So in terms of work product from the group, we have a new RFC number, yay, and a couple others that should be coming up soon. A couple drafts that have passed working group last call. Yeah, that pretty much covers it. First half of the meeting was everything, and the second half of the meeting was, what do we call that thing? Flow spec. So the flow spec work has been a subject of many interims over the last, especially the last year, which actually I think were successful in driving us to something resembling consensus, although you know, we'll tell when we come to the working group last call on those. That's about it. Thank you.
The things to note are probably that the most interesting is that we're going to rev multi-instance ISIS in incompatible way. So we've published it and we're going to change it and it's not compatible. But we've done a lot of research. No one appears to be actually using the old version. The change is basically to allow multi-topology inside of multi-instance. Yeah, so, and then the two interesting sort of things that are new being presented, non-working group items, are geo-coordinates extension and a solution for spine leaf topologies. And then below that, you can see the RFCs that we published since the I think, yeah, since Buenos Aires.
L2 TPXT, I don't see Carlos here, so they didn't meet. They finished one RFC. Their IPv6 one got sort of bogged down in the routing director review, and then I had some comments. So it's back with the authors right now, and they're trying to do two Yang models, and they had a BFD related one just also that got through as an RFC. Okay, Lisp.
So Lisp will meet on Thursday afternoon. We just rechartered it, so we have a lot of work to do, but we are making progress. So since the last meeting, we pushed after last call for publication 2 drafts. We expect to push another one by the end of the week. We will discuss the Yang model for Lisp, and we expect to have a last call, start the last call. And in the coming weeks, we have to review another document, Lisp/sec security, in order to push it as well as for last call. And at the same time, we have a packed agenda because we will start discussion about what we call by now 6830 bis and 6833 bis, which are basically reviewing the main specs for Lisp, because the RFC that we have right now are experimental. Now with the new charter, we will go for a proposed standard, so we have to review control plane, data plane of Lisp. So this is the raw work we will start on Thursday, and we will also start looking at the new work items that are included in the charter.
Yeah, Mene, we've already told you everything we know, and we've made up stuff to fill in the low spots. So, but we meet tomorrow in the afternoon session 1. We did get a couple of RFCs issued. We've got all the documents out of the older charter that was cleared, and we're kicking off the new charter. And I've got an interesting external presentation tomorrow afternoon on some mesh radio technology. So come play.
MPLS, you sort of read it there. We met Monday morning. We have a joint session coming up on Thursday afternoon with TEAS, PCE, and CCAMP to discuss Yang models. So if you like Yang models and any of the before mentioned protocols, show up. We have the RFC 4379 BIS is ready for working last call. I'm sure everybody in this room remembers what it is, but just in case somebody doesn't, it's LSP ping. LSP ping is a very stable technology. It's been out there a long time. It's well used. So in some sense, it's ready to go to full internet standard, except that there's enough changes in this draft that we've decided to sort of first go to, first get the draft finished, then go to proposed standard, and then, after some period of time, go to full internet standard. I do really like the idea of pushing documents to full internet standard. I don't think I'm going to show up at an IETF just because that goes to internet standard, but I think it'll be a good thing. 3107 BIS is ready for working group adoption. For those of you who don't happen to memorize what that is either, it's how you pass MPLS labels in BGP. We have 4 new working group documents. We have a document in Auth 48, which I think, if I counted right, or if Loa counted right, all the authors just responded, like just before this meeting started. So hopefully, since the RFC editor has nothing else to do this week, they've already got it out. I doubt they've already got it out. We have 4 new working group documents. We had discussions of a bunch of stuff: resilient rings, flow identifiers, egress protection, payload indication, and so on. I think that's probably enough.
Okay, Matthew Bocci for NVO3. So we don't meet till tomorrow afternoon after lunch. Main highlights since the last IETF is we have a new working group chair, Sam Aldrin, is replacing Benson Schlieser. So thanks to Benson for his many years of service to the working group. The main discussion point on the list at the moment is that we have 3 data plane drafts, encapsulation drafts, that were adopted some time ago in a working group. That's VXLAN, generic protocol extensions, draft GU, which is UDP extensions, and Genève. And really we need to narrow this down a bit now. And so we're going to have some discussion on the list and in the working group tomorrow about how to go about this, either adopting or continuing as informational drafts, or only publishing one of them, or some combination of those. In terms of the working group status, we've had no new RFCs since the last IETF, but we do have the NVO3 architecture documents, which is there at the moment. We also have had quite a lot of work done on OEM. We have an OEM design team. That's working with the Rtgarea overlay OEM design team. And we also have had some contact with the IEEE related to the split NVE control plane work underway there for the use of VDP. And there is a report back to this IETF in the meeting tomorrow. Thanks.
Okay, so we saved the good IGP for the last. We're meeting Friday, 10 o'clock. The key highlights, segment routing drafts are advancing. OSPF v2 is in publication request. Young model work is advancing. We are at revision 5. There is a lot of activity on the mailing list, also in the design team. There are many applications of OSPF v2 prefix and link attributes. There's a lot of activity there. OSPF v3 extended LSA is sort of stuck, waiting for some implementations. So maybe somebody will write new code. We just heard there is new way to request new code. Maybe we'll request some there. On the overall working group status, everybody talked about seamless BFD. We also published ours. OSPF v3 being able to run over v4 is sitting in the RFC editor queue. And the OSPF two-part metric is also in the publication request. One thing which I missed here is TTZ, which is experimental request, that is also sitting in publication request, waiting for expert review. In the meeting on Friday, there are 2 things coming back from DED. They were initially published in 2012 and 13. One is cross-address family TE tunnels. It's basically a way to just have single tunnels used for both v4 and v6 address family. If you have opinions, please come. We would like to see if there is more interest now, after 3-4 years. Another one is service distribution. That's another way to sort of discover new services and propagate and do all sorts of stuff about services. So again, this draft was there in 2012. Pretty much came back from hibernation. So if you're interested, come back. Thanks.
PALS did not meet at this IETF. First time PALS or PWE hasn't met in many, many years. We are making steady progress on our workload. We anticipate keeping the IESG busy over the next few weeks and months. We published a draft on an RFC on congestion, something that's been outstanding since the formation of all this work. For those of you who want to read it properly, please look at the proper PDF version rather than the machine-generated one. And finally, a request. I'm not particularly good at it myself either, but something that needlessly delays things is failure to respond to IPR polls, the working group adoption and working group last call time. And it's particularly authors who aren't active IETF members that I'd ask people to just chase for us.
John Hoddock, the PCE. So we're meeting, we've not met yet, we're meeting on Thursday, 2 p.m. And then we have a subsequent meeting at 4:20, which is joint with MPLS and TEAS to talk about Yang. Since the last meeting, we have 2 new RFCs. One to update the semantics of the PCE IRO objects, the include rote object, and another one which adds the notion of a sequence of domains to PSEP, so a sequence of AS numbers. We also have another draft with the ISG, service aware draft, and that's progressing through the pipeline. We're still working on finishing off quite a bunch of work actually, so the stateful PCE work is still not quite there, but it's getting close. We're working on secure PCEP, which is also known as PCEP-S, and that's also almost ready. A few other things, enhanced errors, and PCEP is also back on the table. We're still working on finishing off the hierarchy extensions for PCE, and that's just work that we're trying to drag over the line and get done. Some new work's being proposed for the working group this week. PCEP in ACTN networks is going to be discussed. Also extensions to hierarchical PCE, the discovery of hierarchical PCEs, and an intriguing discussion on communicating the TED in PCEP, which should be interesting. That's it.
Mike McBride, Stig Van Haas is the co-chair. Just a reminder that PIM is protocols for IP multicast, not specific to the PIM protocol, although that's mostly what we've worked on. We did meet first thing yesterday morning. We met as a group of multicast experts. MBO and D, the operational deployment working group for multicast, met for the first 30 minutes, and then we met for the next hour and a half. We've done that for the last few meetings, and it's worked quite well. We've published a couple drafts since the last meeting. We continue to put out Yang models for PIM protocols. There was a bit of a discussion that was interesting with regards to in these models, the consensus being features that are included in the lowest common denominator versus a subset. We're hopeful that NetConf and other working groups working on Yang modeling are figuring that out, because there's a bit of debate on what goes into, how much goes into these models. And then lastly, there were a couple interesting drafts presented coming from other working groups, Spring and Beer, that we're evaluating whether to adopt. The Spring one was interesting in dealing with computation of multicast segments in a MPLS-based segment routed network, and using unicast tunnels to form the trees to reduce the state. And then from that, there's other drafts that are specific to protocols like OSPF and ISIS. So heads up to those working groups that there'll be drafts being presented in there as well. And then lastly, as far as these new drafts that we're evaluating, there's one that's coming from Beer that is proposing taking features from PIM, specifically DR and DF mechanisms, and allowing those to be extended to IGMP protocol for the benefit of other non-PIM related protocols. So we'll see how that goes.
Hi, for all. We are going to have a meeting tomorrow afternoon, and basically 2 things. We are going to discuss about our document for use cases that's going to be modified because of the new work on 2460 bits. And we are going to talk about topics for recharging. Thank you.
Justin Routing. So we met today and going to meet tomorrow. Highlights
I'm specifically happy about gRPC work, Rtgarea, which you presented for two reasons. One, bringing open source to IETF, which has been kind of wider effort. Secondly, being relevant. Streaming is kind of very hot topic, and it's good we're discussing it here. So extremely good work on provider side multi-homing. So very good discussions. 3 new RFCs, 3 new drafts, all in Rtgarea. BGP routing, RGC in RFC editor. So very good meeting today. Hopefully tomorrow.
We promised we would publicly shame the working groups who didn't fill out. So if any of the SFC chairs are here, which of course they're not, are you? You can feel ashamed of yourselves. I feel better.
Ready? Go ahead. Okay. Sandy Murphy speaking for CIDR. We meet on Thursday morning. As of last Thursday, we had a light agenda, and as of now, we've got a full agenda. That seems to be how it happens all the time. We're going to be talking about some of the existing drafts, particularly how the respecification, how the validation algorithm works, which we call validation reconsidered, how it's progressing and how it impacts other existing work and other already published RFCs. We have a draft that talks about, that's not yet adopted by the working group, that talks about the requirements spread over multiple RFCs that are contingent upon implementations. We also have a draft that is adopted that talks about how one particular implementation has implemented some of the things and what's the relationship between those. Some work that was presented in previous meetings, not yet adopted, and some updates on that. And then some continuation of the discussion that started at the last IETF about the future of the working group and possible recharter. We have had kind of a productive intermediating time. We've had one RFC published. We've had one document that's in the RFC editor queue. We've filled up the routing AD's already overwhelming burden with publication requested for a number of drafts. Added to one that got to the ISG and they said, we can't look at this until we get the stuff that's coming, and one that is waiting for addressing some of the routing AD's comments. Working group last call just ended for 2 drafts, and it looks, one of them got a bunch of comments that will have to be addressed, and the other one looked like it was in pretty good shape. So adding to your burden again, sorry. And one draft that was presented at the last meeting that's now adopted as a new work. And that's kind of it.
So Spring met yesterday. Since last meeting, we have a new working group document, which has to define how we handle a misconfiguration of seed across the network. It is a hot topic because we would like to optimize for 2 objectives, 2 goals, and we have 2 solutions with different trade-off. And obviously, we will select only a single solution. We also have a new RFC, which is a Spring problem statement on requirements. And actually, that's the first RFC of the working group. And we are about to working group, let's call a set of documents, mostly the initial use cases and the segment routing architecture to fulfill these use cases. And the goal will be to send to the ISG those documents as a single set.
Pawan Bina for TEAS.
We have a regular session on Thursday morning. We also part of this joint young session with PCA and MPLS. That's also on Thursday. In terms of highlights, all the modeling work that's happening under the TEAS umbrella is progressing quite well. They've made some rapid strides in the past few months. We've also seen some good progress on the ACTN front, and we are considering adoption of a document that talks about PCE as a central controller. In terms of document status, we have 2 new RCs, one in the RC8 queue, one under ISGF processing, and one newly adopted document. That's all I have.
Behind you. So Trill is last. What Trill? The topics this time are group keying, ECN, which is a really interesting draft co-authored by Bob Bisco and Donald. That one's alone worth just popping in the meeting, so I won't steal its thunder. And then we're doing some directory servers. We're at Thursday at 6:30 in the evening, 18:30. Come and at least hear the interesting thing on ECN. And I think I'm last.
Yes, thank you so much to everyone for staying the extra 5.5 minutes. All of you know tomorrow at 2 o'clock, the Monet Working Group meets. Now that you all know everything, you can go there and contribute as well. And we'll see you next time in Korea. Thank you so much.